you'll be able to express numbers in scientific notation and switch between scientific notation and standard notation. Now, there are two different ways you can write a number in scientific notation. You can use proper scientific notation, and you can also write it improper scientific notation. For example, say I had a number 1230, okay, 1,230. If I wanted to write that in proper scientific notation, then I would just go 1.23 and multiply it by 10 to the third power. But I could also go 12.3 times 10 to the second power. Now, both of these values are equal, because if I were to take this number and 123 and move my decimal point 3 to the right, 1, 2, 3, I end up with my original number, 1,230. And over here on the other side, if I were to take this number and move my decimal point 2 to the right, 1, 2, then I get the same number. So we know that they are equivalent. They are equal to each other. But this way is proper and this one is improper. And here's why. Over here, if you look at my decimal point, the decimal point is in between the first two numbers. And if you want to write a number in proper scientific notation, decimal point always has to be in between the first two numbers. Now, this over here, the decimal point is not in between the first two significant figures or the first two numbers. And when that's the case, we are using improper scientific notation. So, how can we switch between proper scientific notation and improper scientific notation? Here's how. So I have 12.3 times 10 to the second power, and that is my improperly written number in scientific notation. And what I'm going to do is I'm going to make it proper, and here's how I'm going to do that. I'm going to copy down significant figures, 1, 2, 3, and then what I'm going to do is I'm going to make the decimal point, I'm going to put it in between the first two significant figures, right here, in between the first two numbers, 1.2, and I'm going to replicate that up here. And then once I do that, I need to see in which direction and how many times I need to move the decimal point in order to catch up to the original one. So I need to move the decimal point to the right by 1. I move the decimal point to the right by 1. So if I had this exponent, whenever you move to the right, if you recall, you need to add the number. I went to the right by 1, so I'm going to add 1. So my new number is going to be 1.23 times 10 to the third power, and that is in correct, proper scientific notation. For our next example, let's look at this number. This is improper. Why? Because the decimal point is not here. It is actually here. So this is written in improper scientific notation. So how are we going to write that improper scientific notation? Well, let's rewrite this number, only the significant figures. So that's going to be the 1, 2, 3. We might as well copy down the times 10 to the 5, just to have that. And now, what we're going to do is we're going to put the decimal point where we want it. We want it to be in between the first two numbers. That's going to make it in proper scientific notation. And we're going to duplicate that up here. And then we need to figure out which way and how many steps the decimal point moves to catch up with the original. That's the original decimal point. So let's see what we have to do. We go to the left, 1, 2. All right, so we went left 2. Now, whenever you go left, the exponent goes down. Whenever you go left, the exponent goes down. So I'm going to subtract 2. So 5 minus 2. And my final answer is going to be 1.23 times 10 to the 5 minus 2 equals 3. 1.23 times 10 to the third power. And this is proper scientific notation. And let's do another example. This even works with negative exponents. So this is clearly improper because the decimal point is not in between the first two numbers. So we know that that's improper. So how do we make it proper? Well, let us copy down the significant figures. 1, 2, 3. And might as well copy this down also while we're at it. And we need to put the decimal point where we want it to be. We want the decimal point to be in between the first two numbers, the first two significant figures, and that is what's going to make it proper. So when I put the decimal point there, I'm also going to do that up here, and now I need to see which direction and how many times the decimal point needs to go to catch up to the original. And let's figure that out now. Decimal point has to go 1, 2 steps to the right. So whenever the decimal point goes to the right, you need to add. So I have 1.23 times 10 to the negative 3 plus 2. Okay, I added because I went to the right. And my final answer is going to be 1.23 times 10 to the negative 3 plus 2 is equal to negative 1. And that is my final answer, 1.23 times 10 to the negative 1. That is proper scientific notation. Now, for my last example, here, this is clearly improper. And the reason why is because the decimal point is all the way over here when it's supposed to be in between the first two numbers, but it's not. So that makes it an improperly written scientific notation number. So I'm going to make it proper, and here is how. I'm going to copy down my significant figures, my important numbers, 1, 2, 3. All of these zeros, these leading zeros, are not important. They're not significant. So we don't write those down. We just write down the 1, 2, 3. And while we're at it, we might as well copy down the times 10 to the negative 4, because we're going to need that later. And now we need to put the decimal point where we want it to be. I want it to be here, because when the decimal point is in between the first two numbers, when it's in between the first two significant figures, then that is what's going to make it correct. And I'm going to duplicate that up here so that I can see which direction I need to go, that way or that way. I don't know, but I want to catch up to my original decimal point. So I put the decimal point there, and I'm going to count 1, 2, 3, 4. Okay, so I went 4 to the left. And whenever you go to the left, you subtract. So I'm going to subtract 4 over here, and my final answer will be 1.23 times 10 to the negative 4 minus negative 4. Negative 4 minus negative 4 is equal to negative 8. And that is my final answer, and this is proper scientific notation.